So for this absolute value inequality, I've used a lot of the steps that we use in section 1.3 to solve this thing down to this place right here. Just keeping in mind that this is how I think about it. Whatever steps I would take to solve this are the steps I'm taking to solve this. And I do want to remind you guys that with inequalities, if you ever do have a negative number that you have to multiply or divide by, this inequality symbol has to flip. So I don't know if that'll happen in the homework or not, but over here, had I been dividing by a -2, this would have flipped, but that did not happen. So once we get it down to here, we got to kind of figure out how to deal with this. And what we want to kind of think about is basically what numbers are going to work, what numbers make sense. And as we can see here, it's numbers whose absolute value is less than 4. So just to give some examples, 3.5 has an absolute value less than 4. -2 has an absolute value that's less than 4. But something like, say, like -8, whose absolute value is 8, that would not work. A number like 10, clearly that's not going to work. So it turns out that we want numbers between -4 and 4. So mathematically that means numbers that are more than this, more than -4, but less than +4. It's like literally between them, right? So we're going to take whatever this absolute value is, that's v plus 5, that's what we're taking the absolute value of, and we want to make sure that it's between -4 and 4. That's to say that 4 is definitely bigger than it, and it is definitely bigger than -4. Now from here to solve, you kind of think of this as if it is two separate equations. Like this is one equation, this part of it, and this part of it's another equation. But when I solve it, I'm going to do it all in one fell swoop. So I'm going to go ahead and I'm just thinking back to order of operations in reverse. I'm trying to isolate this v value here, and I can see that that v has a 5 being added to it, so I'm going to subtract that v. But now I've got kind of two different lines, three sides, I guess. Two different equations with 3 sides. I'm going to subtract 5 from every place. Subtract 5 from you, and from you, and from you. And that means that -9 will be less than v, will be less than -1. So that's my solution. And if I have to graph that on a number line, it'll be an open circle on the -9, it'll be an open circle on the -1, and I'll shade all the numbers in between. And if at any point I'm concerned that it's wrong, I'm not feeling 100% confident, I can pick any number from this region that I want. Anything between -1, excuse me, -1 and -9. Let's pick a -3, for instance. Go back to the original problem and see if it works. And you can see if I put a -3 in here, this whole thing would be a +2. Absolute value of 2 is 2. 2 times this 2 is 4. 4 plus 3 is 7, and 7 is less than 11. So however you want to do it. So I hope that makes sense. In the next example that I have you guys try, it's the same thought process, but this is going to be a more than instead of a less than, and that's going to change what happens over here and how the answer looks. So feel free to look at it if it's not making sense, and please email me questions if you have any.